Hello class, we are now going to model the circuit that you see before us, okay? Um, and what we want to do is we want to get these values. So we see that we have 1 kilo ohm here. We'll probably make that a different value, but it's going to primarily be that. But then we're going to find our current across this resistor. And then we're going to measure the value of the voltage across the capacitor. And then we'll calculate our capacitive reactance based on Ohm's law right here. So you'll see that Ohm's law is VC equals to I times the capacitive reactance. And the capacitive reactance is this X sub C. And X sub C is 1 over 2 pi times the frequency of the voltage times the capacitance. Okay, so we're just going to solve for this capacitive reactance first, and then we'll solve for the capacitance. Let's see here. If I go down here, you'll see that we'll have our calculated value for capacitance. So let's do that. And we'll build ourselves a new circuit. That was from a previous lab. So our circuit is going to have a varying voltage source here, and we know that we also are going to have a ground. We need a resistor as well as a cap, okay, capacitor. So let's look at our circuit here. We need a voltage of we need 1 volt root mean squared at 30 hertz. Okay, so I'm just going to go ahead and select this and double click on this. So right now we're at 1 hertz, and we need to change this to 1.41, an amplitude of 1.41 to get 1 volt root mean squared. The amplitude is one side, and so basically a voltage peak to peak of 2.8 volts is going to come out to be 1 volt root mean squared. So here we go. We're going to put 30 here. And so let me show you what I mean. I want to skip it, but I don't need to. So I'm going to go ahead and go over to this page here. So basically, a volt root mean squared is equal to 0.354 voltage peak to peak. So the amplitude, I'll just call it A, is actually a voltage peak. So 2 times the amplitude is going to give us our voltage peak to peak. All right. In this particular case, if we wanted 1 volt RMS, 1 volt RMS, 0.354, and we wanted to calculate the voltage peak to peak, then we actually are going to have to say, well, the voltage peak to peak is just going to end up being 1 divided by 0.354 volts. All right. Now, mind you, we want the amplitude, so the amplitude is not the same as the voltage peak to peak. So we have 1 over 0.354. So you see we end up with 2.82 volts. That would be our peak to peak voltage. 82 volts. But we only want the amplitude, and the amplitude is voltage peak. So that means we're going to take 2.82 volts and divide it by 2, and this is where we get our 1.41 volts from. So if I divide this by 2, we're going to get 1.41 volts. And that is why in this circuit I choose the voltage, the amplitude here to be 1.41 volts. All right, enough of that. I'm going to turn my resistor around. Let's keep the resistor at 1 kilo ohm. And we have our capacitor. I think this capacitor is supposed to be 100 microfarads. So the name of this capacitor, I'm just going to call it a farad. All right. So let's go ahead and put this together. All right. There we go. We have our circuit right there. So the first thing that we need to do is to go back to Moodle. Once we go to Moodle, we'll see that we need our ohms here, and our ohms are just 1,000. So we can leave that at that. And then we need our measured current across the resistor. So let's go and get our measured current across the resistor. Since this is moving, what you're going to notice is our meter here is oscillating for current. So what we're going to need is we'll need the oscilloscope in this particular case. From the oscilloscope, all we need is the current. So let's get rid of the voltage and let's get rid of the power, and this will be our current. And if you look right here, this RMS, typically this refers to voltage, but in this particular case, since we are measuring current, we know that this is in amps. So this is going to be 0.996 0.996 milliamps. Okay, so we can go in here, and if it's going to be milliamps, we know that this is just going to be 0.000996. So that's going to be our amperage. And then we want to know the voltage across the capacitor. So let's go ahead and find the voltage across the capacitor. I'm just going to select this. And so our voltage across the capacitor, the reason why we need our oscilloscope, or we need the scope, is because we have a oscillating voltage. So we really don't need this meter here, okay? And actually we do. The reason why is, let me see, maybe I can change this. We need to change, we don't need the current, we don't need the power, and we don't need the charge. All we need is this voltage, this RMS voltage right here. So we see that it's 52, and that's milliohms. Is that the volt? No, millivolts. 52 millivolts. So if we're going to put this in millivolts, this is going to be 0.052 volts. So now it says, what is your calculated capacitor reactance? Well, if we're going to look at our calculated capacitor reactance, we go right here. We have our voltage across the capacitor, and we know the current in the circuit. We found the current in the resistor. We know that the current is the same all the way through a series circuit, so we can find our capacitor reactance. So let's go ahead and find that capacitor reactance. Capacitor reactance is going to be found here. We know that we have ourselves a voltage already, and that is 0.052, and we need to divide this by the current, which is 0.000996. Remember, that was our current. Uh-oh, I need a point in here though. Okay, so we're coming out with 52 ohms. All right, so we have voltage over ohms. Let's make sure we have that right. Yep. So this is going to be approximately 52 ohms. So now if we want to calculate our capacitance, we use our capacitor reactance here, and we know the capacitor reactance, and so we're going to switch this around algebraically. We're going to move this capacitor reactance to this capacitor and this to this value for capacitance, and we're going to take capacitance out. So we're going to say 1 over 2 pi times 30, which is our hertz, times the capacitor reactance, which is 52. So let's do that. So I just like to do 2 pi 30 times 52. That's just the first thing I would like to do, and then just put that under 1. And we see that we're getting 0.000102. So what that is, that's 100 microfarads. So we move our decimal place over 6 places. That's going to put it in the microfarad arena. So now we just put in 0.000102. Now, our capacitor was already 100 microfarads, so we kind of knew that going in. But this is the idea is if you don't know the capacitance of a capacitor, or if you know what it is, but you know that there's some tolerance that's associated with it, so you want to know exactly what it is, all right? And that's pretty much it for this video.